Yeah, so the paper is like very conventional. It's very like, trying to talk to the people, like so that they can use it practically. But it's just very, in order to explain a way of analysis that would work in other fields and that would actually be able to answer some more fundamental questions. And so again, because of like the way that grant proposals work, I had to pick like a very specific example and I chose genetics. So the idea is that, I mean, the very basic idea is that if you were to receive like genetic information about yourself, you do a DNA test, and based on the risk factors of that DNA, the moment you have like some kind of cognition of that information, whether you believe it or you deny it, it starts to have a kind of impact because your system, your body is somehow sensitive to that information and it changes the genetic expression of like just based on that information. So that was kind of the basic hypothesis.
Mhm.
And I'm not I work with people who do empirical work, so I don't do the empirical work myself, as I'm working on the ethics and the epistemology of it and the metaphysics. So, but basically, I've been obsessed with like trying to find out what is the employment sensitivity with cases we don't understand, right? And I think the reason we don't understand them is because we have a framework that isn't correct or it's incomplete or, And so what I found really interesting in your work, and I mean, I think it works for genetics or epigenetic expression, but maybe it also works for other things like placebo in other physiology that we don't understand. So I have this hypothesis, and I really liked your idea of looking forward rather than trying to explain things backwards. So my forward-looking thing is that if it is true, like this hypothesis that I have now is that the part of the system, the body in this case, or like, the physiology, if that part of the sensitive, like that's sensitive to the prediction, and I take prediction really, really broadly, but the part of the system that is sensitive would be the bioelectric system. Um, so if that's true, if that's what, for example, could explain placebo, then of course I would want to know how. And one big aspect of that I want to investigate is the relationship between our like centralized cognition, let's say, or like the mind or consciousness or just I don't know mental states that would somehow trigger the bioelectric system and therefore create this physiological change, right? So how does that work and what's the directionality? Because I don't know if it's just one directional or both ways or and how would I be able to investigate that or test that? Yeah, and so I wanted to know what you think of this hypothesis, whether you have whether you see possible explanations of how that would work, and yeah, and I have some ideas like people who are working in your lab and people who work in the mind and body lab in Stanford, how that could somehow create a collaboration that would be able to test for these things, unless you already have. Yeah.
Yeah. Thanks. Yeah, very interesting. So, I think a couple of things. I think first of all, I think you've focused on a very important aspect of actually a bunch of different fields, and it's going to be important for biomedicine and everything else. And I gave a talk recently where well, I was answering some questions and talking about this issue of the collective intelligence of the body cells and solving problems in anatomical space and physiological space. And I made the claim that pretty much everything is placebo in the sense that what we're dealing with are activities of an information processing system that's going to make decisions on what it does next based on its priors, based on things it believes, based on prior data and all of that. And so there was a short clip of that of just me saying everything is placebo that was clipped and went online, and then I got like a whole bunch of people saying, "Oh my God, I'm really sick. It's not." I said, "That's not that isn't what I was talking about."
Yeah,
But
yeah.
really, I think what we can bring to this, and there are some amazing people studying, placebo and nocebo and these kinds of things, Fabrizio Benedetti and others. But I think what we can bring to it is kind of what you were talking about, which is this idea that our brainy consciousness and that those mental activities are not the only intelligence in the body, and that we need to understand the interaction between the information that intelligence uses to form its worldview and its self model and its model of the outside world, and how that links to the models that are being made by your cells and your tissues and your organs and so on. And so I think it's a very pervasive topic that's very important in biomedicine and our attempts to control cells and so on. And I think the one thing we know for sure, so we know very little, but the one thing we know for sure is that the problem you pointed out, which is how what's the connection between our centralized integrated verbal intelligence and the rest of the body. Well, the one thing we know for sure is that bioelectrics is the bridge to that. And the reason we know this for sure is that we already know this is how voluntary motion works. So when you wake up in the morning and you have very large scale executive goals, right? You've got goals in these massive financial spaces, social spaces, these very abstract things, but your cognition is able to use them as goals, and you're going to go meet those goals with certain activities. In order to get up out of bed and do that, those very high level abstract concepts eventually have to make your muscles contract so that you can get up and execute on those goals. And we know the system that does that, and it's neurophysiology, right? This has been studied for a couple of hundred years now. This idea that these large scale mental constructs eventually make the calcium and potassium ions dance across your cell, your muscle cell membranes, and the interface between those mental events and the chemistry that drives your muscle motion. I mean, it's an amazing thing. It's these kind of ineffable mental concepts are actually making chemistry change in your muscle cells every day, all the time. So people, when I talk about this, that I say, you can, with the power of your mind alone, you can depolarize maybe 30% of your body cells, and people think this is some kind of crazy yoga or biofeedback or some weird anomalous thing. It's just voluntary motion. It happens 24/7, in your body. And so I think we know that bioelectricity is critical there. And the two ends of this are the neurophysiology of that connects the mental states of the human to things that happen, and then there's the other side, which are the cognitive states of the rest of the body, which are also going to make decisions and how they navigate the space of physiological states and so on, based on beliefs in those two things. We've done some work on that, how those two things interact, but yeah, I mean.
Okay, so maybe like two questions. So one would be very specific, right? It's just about the genetics. Like to explain, because I get we have to like chunk this up into small parts to like sell it to the scientific community. But like,
yeah.
If so, right now I just finished a paper with a geneticist that just basically maps all the different kind of self-fulfilling and self-defeating mechanisms in genetics, and a lot of them we know, we understand them, we use them in order to create therapeutic interventions. So we mapped most of the conventional things, and we touched upon some that were kind of more, missed in typical practice, but it's all very conventional. And now I'm trying to kind of write a new paper that would explain, a more unconventional understanding of what's really happening when it comes to genetic expression, for example, or even that kind of sidetracks that maybe it appears to be a change in epigenetic expression, or that it appears as a genetic change, but actually what's really happening is something completely different, which is the kind of stuff that you guys are doing, right?
Yeah.
That's like the small version. The bigger version, and I think this is important to mention, is because all of this stuff is very small, and I think all of these questions I ask myself are all different examples of a more fundamental concern, especially in philosophy, that I mean, that's probably what keeps me up at night. And I want to know what you think about that and in relation to your work. So for me, based on the fact, like you said, one thing we know for sure, I feel like I know nothing for sure. And I think, yeah, like, so what it gets me thinking is, whatever we know, and that's why I said, I take prediction to be very, very broad, in the sense that every time we say anything about anything, that is still has a degree of uncertainty, which I think almost everything has a degree of uncertainty. So everything we say about everything, if we say it or if we express it with assertion or some kind of assertoric force, then we're basically making a prediction because we are inviting more credibility than maybe it deserves, right? Or something like that. And so that means that, I find that very like I ended up specializing in ethics of prediction, even though I think prediction is very problematic and I don't think we should do it as often as we do, or we should at least be aware of the fact that we're predicting and all that. And so my big concern, like existential concern, is that given the fact that we probably have faulty assumptions, like everything we know builds on the bottom ones that we cannot prove or that we don't understand or that and so given that, given the fact that we have these faulty assumptions or incomplete assumptions, how come the world like presents itself to our experience or presents itself to us in a way that we would expect it to? And so the two possibilities, there's probably more, but I see two that I'm really torn between, like, or I was. So either the world presents itself to us the way we would expect it to, despite the fact that we have these faulty assumptions, or it presents itself to us the way we expect to because of our faulty assumptions. And so that's where it really comes down to, can our centralized cognition or our experience of the physical world kind of change the physical world? Like, this whole mind, like mind over matter, but it's not really, I think that's too simplistic. But anyway, that's kind of the gist of it.
Yeah. Okay. A couple of things. First, the stuff about genetics, and there's two things I recommend to think about. One is, if you want to stay conventional, which is not a bad idea, because in my experience, when you're writing something or giving a talk or whatever, typically people can handle like one new idea, right? Like what you if you're saying all these different, which I'm totally guilty of running a file because I say all kinds of crazy stuff, but typically you want one battle that you want to fight in any particular paper. So if you want it to be conventional on that way, you could say, fine, genetics is what most people are interested in. The mechanisms by which bioelectric states influence gene expression are well known. We have characterized them over the last 20 years. It is known how it is that bioelectric states change gene expression. So you can make a pretty a solid chain where, if, as neuroscientists believe, our thought, memories, beliefs, and so on are in some way encoded in the bioelectrics of neural and other networks, we now have the molecular mechanisms to say this is how it's going to change your gene expression, right? There's no mystery. There's no magic step there. They're all known.
So you're even skipping a step of like, how would the beliefs, the mental states, the changes in our identity or our perception of identity influence the bioelectricity? You say no, it's already in there. It's already in
Well,
the.
well, it's. I mean, so I'm not trying to say that neuroscience is solved by any means. I don't think it is, but it is not a controversial claim that whatever beliefs you have about what's going to happen are in some way encoded in the electrical properties of your brain cells. This is, I think, what almost every working neuroscientist thinks. That the electrical networks. What I am doing that's a little different here is I'm purposely fuzzing over the difference between neural electricity in the brain and non-neural electricity in the rest of the body. Okay, and there's good reasons to do that. But the first part of it is completely conventional neuroscience. If you went to the neuroscience meeting and you said that you didn't believe that people's thoughts and beliefs were encoded in electrical state, everybody would turn and stare, right? Like this is completely conventional neuroscience at this point.
Okay.
so that part is, no one's going to argue with you over that part, even though there are many questions about neuroscience and how that works. That part's completely conventional, and so what you could lean on then is to say, look, we already know that inputs, meaning things you hear and things you read and the results of tests and all of that, are altering the electrical information in your brain. Okay, that's completely conventional. From there are known mechanisms by which that is also going to filter down to gene expression in tissues. So I think you could stick to entirely known published work to make that link. That's
Hey, that's really good news. But then, like I tend for my audiences who are very like I don't want it to just be philosophy. I want it to be like usable for like
yeah.
clinicians and stuff. And then the question becomes like, how can I give like practical examples of that? Unless they've already been done, like
Right.
practical examples of where a change in belief would result into like a physiological change, without getting like uh my head shot off or something.
I mean, there are more flashy examples like gene. I mean, there are papers on gene expression being changed by music, by meditation, by there are papers on that kind of stuff. But the far more conventional version is
Yeah.
that if you sit there and deliberately focus your attention on things that stress you out, the world situation, whatever it is, right? You sit there. I'm gonna take a half an hour and I'm gonna think of all the things that are freaking me out right now. So if you do that, your cortisol is gonna go up, your adrenaline is gonna spike, all these physiological things are going to happen. That's either totally mysterious or completely non-mysterious, depending on how you understand neuroscience. But this is something, this is not an exceptional human experience. This is an everyday thing. So you get yourself all worked up. When you've managed to activate your nervous system in a way that's causing stress and turning on cortisol, it is not controversial that at that point many cells are changing gene expression. Of course, they're going to change gene expression. They're being bathed in cortisol. They're being, your heart rate is going up. I mean, of course, cells are going to change their gene expression. So,
But enough to create like a lasting, like a permanent physiological change.
well, now that's a slightly different thing, right? If you want to show that, I mean, I'm not a clinician. I don't know, but it seems to me that from my reading of neuroscience, and I think here you would have to talk to some clinical neuroscience people. There are thoughts that are persistent, meaning that, and obsessive, meaning that once you start thinking them, they sort of are hard to get rid of, and they do a little bit of, and this we are writing something about a little bit of niche construction, where they're actually changing your brains slowly over time to make it easier for those thoughts to keep recurring. So if you talk to people who study depressed brains and how they got there, and not there's multiple, right? There's the version where you have some mutation that gives you a serotonin disorder, imbalance disorder. We're not talking about that. We're talking about people who have acquired the various pathological states because of modes of thinking, because of things they've experienced in the environment, abuse and stress. And it doesn't have to be physical abuse, right? There's a huge literature on this. So all of that exists, and all of that certainly has long-term implications that of course include gene expression. Now, you said something else before that, which is much harder, which is, how do I give people a practical, now with this knowledge, here's what you can do therapeutically. I mean, that's hard, right? And I don't think you should expect to be able to do that by yourself. I think there are many people working on this in labs, but I think together with them, the philosophical perspective that you bring could actually be incredibly useful.
Yeah.
So that's okay. So the standard version is just to lean into neuroscience and say that, yes, we know these things are all electrical in nature, and of course it changes gene expression, as every physiologist knows. So that's fine. There's a less conventional version of this, where you can actually point out that gene expression is fine, but there are many, many things that are driven by other layers of biological regulation that has nothing to do with the genetics. Now that's a whole other huge battle. I don't know that you want to fight both of those at once, but certainly
I do.
something
I do.
we're
I think I'm already kind of done with the genetics part, like the
yeah.
epigenetics part. So basically, one of my concrete questions would be, the stuff that you're doing with like, bioelectric interventions that cause like, a planaria to have two heads or cancer to stop being like behaving like cancer
Yeah.
or like conventional cancer. Do you think, so for example, if we talk about like natural remissions in cancer, um, would there be a possible relationship between, your beliefs, your cognition, everything we've been talking about in the centralized thing, that is related to the bioelectric cognitive glue in a way that changing those beliefs can have these kind of physiological, like that that they can create the kind of interventions that you're doing in
Yeah.
your life.
Yeah. Yeah.
That's much
Okay.
more what I'm interested in. I'm sorry, I need to not take this. I have a very problematic. Yeah, sorry.
Okay, so I want to be really careful here. What I am not claiming is that right now, today, we have actionable protocols where somebody can, with the power of whatever positive thinking, they're going to get rid of their cancer. So I want to be very clear that we do not have this today. Okay, I'm not saying there haven't been examples of this, maybe, but by and large, you cannot count on something like that working. You need to get proper treatment. So that's the first thing. However, looking into the future, I do think that the biomedicine of the future is
Mhm.
basically going to be this. It's basically going to be taking what we already know happens, that various kinds of thinking changes the way that ions move across your muscle membranes. There has got to be, I think, a way to capitalize on that system, which is already in the body, to make the same thing happen in other cells that are not muscles. And once you can do that, the path to then saying, to recapitulating what we do externally, which is to use drugs and other things that will hyperpolarize, for example, nascent cancer cells and so on, and cause them to normalize. Uh, that seems perfectly plausible to me as a future research goal, and in fact, that's exactly what we're working on. So I think that is going to be possible. I don't think it exists yet.
No, but I do think it exists naturally in the sense like if this hypothesis is true, like if you can prove it, that could explain natural remission right now. I'm not saying per se to positive thinking or something like
Yeah.
that, but there, people who make like extreme big like identity shifts, like just because they've been given shorter time to live, they make
Yeah.
different choices, they change their entire behavior, and their behavior has been changed by something fundamentally shifting in
Yeah.
their brain, right?
What
So.
yeah, but what I don't know is whether the number of people that have experienced remission because of that is less or greater than the number of people who, right, forego traditional therapies. They're going to go to some sort of alternative thing, and they really believe that it's going to work. They really do, and they end up dying of it because you're right. And not that the conventional approach is actually that much more effective. At least in cancer, it's really not. But the point is that aspect of it is probably real, but entirely unreliable at this point. You don't know when it's going to happen or how to make it happen. So I'm not saying it's not real. I'm just pointing out that you can't really trust it yet. And we are working to understand it so that we can make it work like Tylenol. When you take a Tylenol, mostly your headache goes away, and you can count on it every single time. That is how we want it to work. We don't want this to be some mysterious thing that and I'm not saying we are mechanical machines when everything's going to work like a calculator. That isn't it. But it has to be reliable. It has to be that people can count on it because we understand how it works. The other thing I just want to come back to real quick is your point about whether we see the world despite of or because of our beliefs, right? So there's a lot of work on this in terms of active inference and things like that around people like Carl Friston and Don Hoffman and things like that, where and lots and lots of neuroscience going all the way back to many decades to understand how it is that we organize our world. I think the one thing we can say is that what we perceive is an extremely narrow slice of reality,
Oh yeah.
and right, and whatever it is that we are
I don't
when
even think it's a slice. I think it's probably more like an interpretation of a slice or something
well
like
well
that.
that was the next thing I was going to say, is that we are perceiving a small slice, and we are turning it into a model of the world that facilitates us doing certain things, good enough to survive, which is mostly what evolution cares about, and it keeps us from doing and seeing lots of other things. And so,
Completely dependent on the senses we have, right? Like we have a spectrum that we see, we have a spectrum we hear, but it's so small and it's such a, such
yeah,
a
there's that. There's the actual receptors that we have, and what can we actually detect of the outside world. But then there's the cognitive architecture that we have. How do we put those stimuli together into some picture of what the heck's going on? We have lots of very strong assumptions about space, about time, about what makes for agency, and things like that. And
yeah.
and all of that gives us a very particular picture of the world
Yeah.
that strongly
Yeah,
constrains.
I don't think I mean, yeah, I think that's why I run into so many problems because I don't think I share those views.
Yeah. Well,
So I want to ask you three more like practical things. One, you said I don't have to do this alone, and yeah, of course, I've been very lucky with the sciences I've been working on. But like a lot of geneticists and epigeneticists were like, we can't help you here because this is going. We have no explanation for this, right? And so I think your work of your lab and Ellie Crum or something, I think from Stanford, who works on placebo. She's like a student of Langer and then Ted Kaptchuk and stuff. So it would be really great to work. Like I kind of told myself I wasn't going to apply for another grant, but if I can like chase this idea that I have and work with like people in your lab or people who doing empirical work in the mind and body lab who are just really testing the more psychological part of the like they're used to testing placebo basically.
yeah,
Um, and then they did a study where they were studying the placebo and epigenetics.
yeah,
So that would be great. Also, like if I could write up this like first more conventional paper, it would be great if I could send it to you or someone in your team to either review it or co-author. Um, and there's another thing that I'm working on with a gynecologist. I don't know. English is not my first or my second language, but someone who works with in reproductive clinics, and she's in Japan. And we've been working on a paper where we see all these self-fulfilling and self-defeating prophecies in implantations of like these abnormal embryos. But I think your work explains it perfectly in the sense that, we don't see how all these abnormal things in vivo are just being
yeah,
solved
sure,
by itself.
for
And I
sure.
think really like to talk to you and like maybe I don't know if that would be possible at all. And then finally, I have a personal question, which obviously you don't have to answer, but I would be very happy if you did. What is like, I know you only like you're at, I don't know how far you are like telling what you think, but like 75% as I last read. So, what's like the craziest idea you've had in the last 6 months? And I'm not talking about conventional crazy, like what everybody else would think is crazy, but like where you think like you have a thought and your next thought is like, am I really thinking this? And then you have no way of kind of denying or like just dismissing it for being false because you just don't have proof.
Yeah.
Is that
Okay, yeah, okay. And I apologize. I've got literally a minute before I'm going to get pulled off of this to the next meeting. So on the first stuff, at this point, I don't make a very good co-author because I'm sitting on about 150 open manuscripts that I'm trying to write, and so we will both be old and gray by the time I write anything. So I encourage you to find other people. There are plenty of, you might reach out to Fabrizio Benedetti, and there are many other people. But I'm happy to kind of look at things and talk to you and provide advice if I can. I'm just not a great co-author right now. So that's the first thing. I guess with respect to the crazy ideas. Look, for me, I have a lot of crazy ideas. Most of them I never talk about, and the reason I have a simple criterion. All I want to know is this idea. I think crazy is a crazy or not crazy is a bad classification. I think what's a good classification is this idea. Can this idea be baked to the point where it can actually help do something new? And so all the ideas I have, people send me all this stuff about God and the universe and all this stuff, and my question is always the same. That's all great. What are you going to do with this to move forward? Okay, what is the next step that this lets you do that you otherwise couldn't do? So my wildest ideas, and I'm sorry, I got to go, but some of my wildest ideas, what I spend all my day thinking about is how do I turn this into something practical? And if it can be turned into, and I don't mean a widget that we're going to sell, I mean a way to move knowledge forward. And if we can turn it into something useful, then I'm in, and I don't care how divergent it is from anything that's been done before. And if I can't, then I'm probably not going to pursue it, no matter how pleasing it might be to me, because it's not going to do anybody any good, right? So